Welcome to the video. In this video, we are going to learn how we can factorize the algebraic expression using the identities. Let's try to understand. In this video, we are going to learn the third entity. So let us first try to understand the identity which we are going to use, although you must have learned this identity in your earlier classes and in the algebra part as well. So the identity says that the difference of the squares of the two numbers, that means a square minus b square, is equal to the a plus b times a minus b. That means if I have any two numbers and we are squaring and then subtracting, that would be equal to their addition multiply their subtraction. We are going to use this identity to solve the basically to factorize the algebraic expression. Here is one of the example. Factorize 4p square minus 9q square. So let us write the identity once again. So the identity was a square minus b square will be equal to a plus b times a minus b. Now, first of all, that we need to keep in mind whenever we are factorizing is that we have to take commons. So, can we take commons among these two terms? Well, no, there is nothing can be taken as common. So, the second step is to think about the identity. Can we apply any identity? Well, yes. Let's see how. So, 4p square, I can write 4p square as the 2p whole square minus, and 9q square I can write it as 3q the whole square, because the square of 2p is 4 into p square and square of 3q is square of 3 times square of q. So if we think about this identity, we can say that our first term a is my 2p and my b, the second term, is 3q. So using the above identity, we would be having a plus b, that means 2p plus 3q times 2p minus 3q. That means we were able to write the given expression in the product of two expressions. That means we were able to factorize. Let us move further and try to understand through one more example. 49x square minus 36. Again, can we take anything common? No, nothing can be taken common from any of the term. So let's see if we can apply the identity. Well, yes, we have 49x square, which I can write 7x the whole square minus 36. I can write square of 6. Now we have our a as 7x and my b is 6. So using the above identity, we would be having a plus b, which is 7x plus 6 multiply 7x minus 6. So that's how we can use the identity to factorize the expression. Let's move with one more example. Here is another expression which says 9x square y square minus 16. Let's learn how we can factorize. Again, I cannot take anything which is common. Then what we'll do? Can we apply the third identity? Well, yes. Let's try to understand. So again, we'll can first write the identity. What was the identity? The square of a minus square of b will be equal to a plus b times a minus b. So I can write 9x square y square as 3xy the whole square minus, I can write 16 as square of 4. So my first term would be 3xy and the second term is 4. So using the above identity, we can write 3xy plus 4 multiply 3xy minus 4. That's how we can factorize. The last but not the least is 16x raised by 5 minus 144x cube. Now, the most important rule of the factorization is to take common. Can we take common among these two terms? Well, yes. The first thing, always try to take common. So I can take common is x square. Now after taking common, what is left? Sorry, I should say I can take common as x cube. X cube is the highest number which can be taken as the common from both of them. X raised to 5, that means x into x 5 times. X cube means x into x into x. So I can take x cube as the common. Now after taking x cube as the common, from the first term which is left 16, and if I divide x raised to 5 with x raised to 3, I would be having x square minus 144 x raised per 3 divided by x raised per 3, the same, 1 only. Now x cube as it is. Now 16x square I can write it as square of 4x minus 144 I can write it as square of 12. Now using the same identity again, we can write our expression as x cube remain as it is, 4x plus 12 and 4x minus 12. Well, I just forgot one thing, that we can also take common the 4 as well. 4 can divide 16 as well as 4 can divide 144. Well, no problem. I can take common now. In fact, I can take 16 as the common. 16 can divide 16 as well as 16 can divide 144. So why not, let's correct our mistake from here only. We can take common 4 from here as well as 4 from here. So taking the common from the first expression, the 4, I will get 4 from here as well as 4 from here in the multiplication. So that means 4 times 4 I will get, which is equal to 16. So outside we will be getting 16x cube. And when I take common from the first expression, I can take, when I will take 4 as the common, so I will left with x plus 3, multiply again, I'm taking the common 4 from the second expression, I'll get x minus 3. So that's how we can solve the expression. In the next video, we are going to do a couple of more examples. And till then, do like, share, and subscribe to Mathematics Masters.